So in this video I want to prove the derivative with respect to x of the exponential function e raised to some function of x. And to do so I want to start with the derivative with respect to x of e to the x, and then I'll use the chain rule from there to prove the other. So to prove this derivative, there's a lot of different ways to do it, but what I think is the easiest way, I've already proven in another video that the natural log of x, or the derivative with respect to x of the natural log of x, is equal to 1 over x, and that the derivative with respect to x of the natural log of some function of x is equal to the derivative of that function over that function. So using this property with the derivative of logarithms, we can get our exponentials derivative quite easily, because we know by their definition as inverses that the natural log of e to the x is equal to x, because we can use our log property, pull the x out in front, natural log of e simply 1, so that's our inverse property. So if I take the derivative with respect to x of both sides of that equation, what am I going to get? Well, with the natural log, I'm going to get the derivative of e to the x, whatever that is, its derivative divided by e to the x. And it's going to be equal to the derivative with respect to x of x, which is simply 1. So I don't know what the derivative of e to the x is, but I know that whatever it is divided by e to the x will equal 1. Well, if I just multiply both sides of that equation by e to the x, I get the derivative with respect to x of e to the x. Multiplying by e to the x clears the denominator, and that's equal to 1 times e to the x, which is just e to the x. And this is shown here, and we can prove it in a lot of different ways, quite possibly the most amazing derivative of all, that the derivative of e to the x is equal to itself. And the second derivative and the third derivative and so forth, an infinite number of derivatives of e to the x will still equal e to the x. So what if we don't have just x, but we have some function of x? If it's the derivative of e to the f of x. Well, here we can use our chain rule again. So we can say that g of x is equal to e to the x, and that h of x is equal to f of x. So if we do that, that means g of h of x will equal e to the f of x. So we can say that e to the f of x is equal to g of h of x. Well, we just use our chain rule on that. The derivative of g of h of x will be g prime of h of x times h prime of x. Well, what will that be? G prime is going to be e to the x because it's its own derivative. So that'll be e, but instead of to the x, it will be to the h of x. And it will be multiplied by h prime of x. But what do we know? H of x equals f of x. So that means that e to the f of x times f prime of x is indeed the derivative of e to the f of x. So what do we really do with that? We just take the derivative of the exponent and multiply it by the original exponential. So I'll give you a concrete example. If we want the derivative with respect to x of e to the x squared minus 4x plus 2, well, that's simply going to be e to the x squared minus 4x plus 2 multiplied by the derivative of that exponent, 2x minus 4. So this is really a quite simple rule, and it's quite amazing to see the derivative of e to the x being itself, and to see how simple our rules are with the natural logs and exponentials. But with those we can do a lot of other things in many different applications and in many different derivative rules.